Welcome to One Question at a Time, the TSI series. Question number 20. Under ideal conditions, the population of a certain species doubles every 9 years. If the population starts with 100 individuals, which of the following expressions give the population of the species t years after the population started, assuming that the population had been living under ideal conditions? So we have is double every 9 years. And in the ideal conditions, so we know that it's under ideal conditions, so yeah, it's matched, right? And then we start with 100 individuals. We highlight all the given informations. Then they said that if after t years, so what is the expressions that give the populations of the species after t years, right? After it starts. Okay, so let's write down the given informations. So for example, if we have start at 0 here, right? The time is 0. It start right here. And then this is 9 years. Then this is maybe 18 years, right? So we start with 100 individual. We start 100 here. Then after 9 years, we will have 100 multiplied by 2. Then we have here is 100 multiplied by 2 individual, right? Then next we will have 100 multiplied by 2 multiplied by 2. Here we go, right here. So right here we'll have 100 multiplied by 2 square. Here is to the 1. And then we continue, right? So every 9 years, the populations will be the first one 100 individual multiplied by 2 because they double every 9 years. And then from that 100 times 2, after 9 more years, they will get 8. So after 18 years mean right here at 9 more years. Okay, this is at 9 years. Okay, so from 0, this is the time that in years. Okay, this is the number of the populations. We start with 100. Then after 9 years, we will have 100 multiplied by 2 to the power of 1. Then after 18 years, we have 100 multiplied by 2 square. So how we see the formulas? I mean not the formula, but like the expressions close to the answer choice, right? So we know that the 100 doesn't change. Is the start number, like the number we start with, like initial populations, right? So we'll know that our expressions will somehow have 100 multiplied by 2, right? So 100 is what we begin with, multiplied by 2 because it's double, so the base will be 2. And then we have some kind of blank right here. That is the exponential, or like the power of base 2, right? So that the populations will be, we say the population is the function of P of t. T mean time, P mean population at that point, right? So now we see if t equal 9, then let's say here is n. Okay, let's say we want to find n right here. So n equal 1 when t equal 9. And then when t equal 18, we have n equal 2. So how we represent n in terms of t, right? So to be 1, we have to do t divided by 9. N equal 2, we have to do t divided by 9, right? In the first case, we have 9 divided by 9 equal 1. In the second case, we have t equal 18, we divide by 9 equal 2. So the answer should be D. So P of t equal 100 multiplied by 2 to the power of t divided by 9. So for the first, looking at how it look like, we can eliminate A, choice A, because 2 is by itself. It's double every time. So the next time it multiply by 2, multiply by 2. So we multiply by 2 more than we do with 100. So it's nothing to do with 100 to the power of the 100. So the 100 is the initial populations. Okay. So for the double, we know that the base, and then we have the exponential equations, right? So we know that, and 2 is double, so that's the base. Our target is find what is the power of the base. So based on that, we eliminate B because I have the 2 in front as well, the 2 for like by itself. And then for this one, C and D, you can know that if after, we know that after 9 years, for this one, after 9 years, t equal 9, you will have the populations is equal 200. And that's true. That's what we link right here. 100 times 2 because it's double. But look at this. After 9 years, you will have 100 multiplied by 9 to the power 2 to the power of 81. 9 times 9, right? So that's not right. That's not right. Based on that logic, we know surely D will be the answer. And also, we know that we have the formulas for the population row. Is we have the populations of the time t that equal the P naught. P naught mean the initial populations. So when what you start with, okay? In this case, P naught is 100. Then you multiply by the raise. You double or you triple. Triple mean you multiply by 3, right? The base. So you have the base. Let's say the base of how much you increase the populations raised to the power of the time divided by, let's say, the year. So it would be like the year when it do that space, right? The year to multiply by the base. Like when it double, or when it triple, or when it's multiplied by 4 times, 5 times, So the years, so every 9 years, that's why we put 9 here. T is how many years, and then how many years until it's double or multiplied by the base. Thank you for participating in this series. See you next time.